evening carbon mat, then you can see all the products are made by the polymeric material. So in compared to ceramic and metallic material, this type of material has some advantages. And if you see the wide application area in automobile sector, particularly in packaging, agriculture, medical, electrical, electronics, building and construction industries. If you why we are thinking polymer or plastic in our daily life? Because it is very lightweight, it is very cheap, and material cost is very low. Melting temperature and processing temperature also very low, processing cost also very low, no rusting problem, and thermoplastic material can be recycled again and again, and some of the material are biodegradable in nature, and longer shelf life, I mean service life is very high in compared to metallic and ceramic material, and wide application area in our day-to-day life. But if you see the heat resistance property is very poor in compared to metallic and ceramic material. If you see for high temperature application, only ceramic and metallic material is suitable in compared to plastic material. So apart from the thermal stability, all other properties in terms of material cost, in terms of processing, and it replaced the so many metallic material, because some advantages of its lightweight, processing cost, and it can be recycled for the case of thermoplastic material again and again. If you see the worldwide scenario, different sector, different this plastic material will use in various sector, particularly in packaging sector 35%, footwear 1%, mechanical engineering, medical purpose 2 to 3%, toys item, sports item 3%, other 3%, transport, agricultural 7 to 8%, furniture, household item 8%, electrical 8%, building and construction industry 23%. So these are the scenario of various industries for use of polymeric material in different sectors. Now the problem is the waste. With increasing the population, demand of the plastic are gradually increases, and after using the littering problem, particularly in India, we are throwing the plastic here and there, so that will create problem in environment. And waste is basically the unwanted substance after using, which we throw outside, that will create in problem in environment. At the same time, disposal means it can be used, it is a operation which may lead to resource recovery, recycling, or direct use or alternative use. So recycling is a very good part of the plastic waste management, and we can make the various product by using the recycling plastic, particularly for plastic bottles, carry bags, and other plastic waste. So landfill, we can protect the environment, and we can protect the pollution, we can protect the greenhouse gas emission by using this recycling technology. I will gradually describe about the recycling technology. Before that, around worldwide, almost 40% of the waste disposed in the landfill purpose for plastic, about 19% undergo material for recycling, and composting 4% and 11% treated as an incineration purpose, and 33% waste material goes for dumping purposes. But recycling is the by sorting, segregation, by mechanical process, we can recycle this material for making the various products. Now I'll go for about the PET history, how PET is prepared, and what is the technology for recycling of this PET material. You know, PET is basically polyethylene terephthalate, commonly known as the simply PET. PET is the polyethylene terephthalate. It is nothing but the polyester. It is a condensation product of the ethylene glycol and terephthalic acid. By reaction, condensation reaction will take place between ethylene glycol and terephthalic acid, and it will form a PET polymer. After condensation, as you know, for condensation reaction will take place by reaction between two functional groups, and each monomer containing two functional groups, they will react to each other, form a condensed product by the elimination of the water molecule each and every step of reaction. And in this case, the polyester and PET is basically ethylene glycol and terephthalic acid combination. It will make the PET polymer, which is suitable for various application, particularly in bottle application. In various country, ton production of the bottle. Some of the country, they are producing the PET fiber for production of the textile industry. The bottle industry is basically due to its excellent physical and chemical properties, because a barrier property for this material is very, very good, and strength and chemical resistance property is very high in compared to other materials. If you go for synthesis of the PET, and if you see the properties, the PET is a polycrystalline and amorphous material, and which is a combination of the terephthalic acid and ethylene glycol combination, and sometimes transstratification of dimethylene terephthalate with ethylene glycol. Synthesis of the PET, either the process in two steps of reaction. If you see the reaction of synthesis of the PET, DMT react, dimethylene terephthalate react with the ethylene glycol and form the PET. Terephthalic acid also ethylene glycol react the PET polymer. Physical and chemical properties, if you see, it is amorphous, and both crystalline and amorphous nature of these materials are there. It depends on the temperature boundary. So it is interesting to note that the barrier properties and amorphous PET are basically transparent, and crystalline PET are basically opaque, and the amorphous glass-like material, it form a transparent in nature. So the commercial, the melting point commercially, it in between 250 to 260 degrees centigrade, and for the crystalline material is 265 degrees centigrade. If you see the application for production, excellent tensile strength, chemical resistance is very good, clarity, processability, and reasonable thermal stability also there. PET has been wide application area in worldwide, particularly for 60% material goes into the fiber production, particularly in the textile industries, and other sector, particularly in the food packaging sector, automobile products, light oil products, sporting goods, and food packaging sector, because its transparency and good barrier properties, and excellent barrier properties against oxygen and carbon dioxide. So it is used for soft drink bottle purposes. Demand of the plastic in the gradually increases globally, and by 2019 to 2021 onwards, due to high production of the fiber and PET resin for bottle, film, and other application purpose. If you see the for automobile sector, if you see the film sector, transparent film, PET resin for bottle manufacturing unit, and fiber production for this polyester PET material is worldwide, play a very important role in our daily life. In Europe and in America, basically consumption of the PET is very, very high for bottle production. But in Asia, if you see for fiber, high production of the fiber, for the production of fiber. So growth of this country is basically done by industrialization of the fiber based or textile based industries. Recycling is a very important after using this lot of product, and when the production and consumption is very high, at the same time the waste also generated by this material also very high. After using, when we are throwing this plastic or PET material into the environment, it create the problem in environment. So recycling and sustainability is a very, very important term for this PET recycling process. So particularly for petrochemical industry, recycling is the one of the most important solution, main driving force for PETs. Recycling is not the cost reduction, but the business sector embracing the sustainability ethics and public concern about the environment. PET recycling method is basically done by four process, that is primary, secondary, tertiary, and quaternary recycling. Primary recycling involve the recycling, also known as the extrusion. Same material we are producing in plant recycling process. The same material we are producing, bottle to bottle we are making the same material. This is called the primary recycling. That means by extrusion process, from bottle we are making another bottle. That is called the primary recycling. And secondary recycling, also known as the mechanical recycling, which was commercialized in 1970s. It involves the separation of the polymer from its contaminants and reprocessing to it granule via mechanical means. Mechanical recycling steps include sorting, separation, waste removal of the contaminants, and reduction by crushing, grinding, and extrusion by heat. Among the main issues of the secondary recycling are the heterogeneity of the solid waste and degradation of the product and property at the time of recycle. Tertiary recycling are more commonly used as a chemical recycling. It involves the transformation of the PET polymer in polymer chain, usually by means of solvolytic chain cleavage. This process can be a total depolymerization back to its monomer, or partial depolymerization to the oligomer. And basically chemical recycling process, the PET will convert PET into its oligomer and monomer by the treatment of the alcohol, by the treatment of the acid, by glycolysis, aminolysis, and water treatment. Quaternary recycling is basically done by generation of the energy by collection, sorting, separation, segregation, and by burning. And the energy will generate, which can be used for utilization for different purposes. However, the economically unacceptable due to potential health risks and airborne toxic substances during burning of this PET and other plastic material into the environment directly. So incineration by process, we can burn and we can generate the energy for using this material. Now I'll show you the some problems associated with the environment. If you see it will create a problem by littering problem in the plastic bottles and other plastic. It destroyed our nature. It destroyed our ecosystem in the pond and other environments. If you see the littering problems of the bottle and bird, and if you see the sea bird, if you see for fish in pond, if you see for plastic granules, it destroy our greenery, particularly for grass and other plants. So recycling is also some animal also affected by direct or indirectly by consuming this plastic bottle. and other polyethylene materials. Why plastic is suitable for packaging? And plastic is suitable for packaging duties, and food industry duty is very lightweight and cheap, and also barrier property, and it can be recycled. More than 30% of the material goes into the recycling sector nowadays. So but the consumption of the plastic is gradually increases day by day. Plastic bottle also consumption is very high in worldwide. If you see the scenario, the globally it is high demand in various sectors. So after using, when we are throwing outside, this will create problem in environment. So it should be recycled in various process, by mechanical recycling, by chemical recycling, by enzymatic recycling, and by generation of the energy, and by other process also we can minimize this problem. And most of the recycling, an important method of the pyrolysis method, we can generate the different aromatic hydrocarbon, aromatic and aliphatic hydrocarbons by using this method. And also we can generate the carbon, which is used for adsorbent material and for the wastewater treatment, for active, by using this active carbon. Sorting, segregation, and chemical recycling method, we are using some different ionic liquids for recycling purpose. I mean, for depolymerization, polymer to converted, it is the monomer, by glycolysis, methanolysis, hydrolysis, and some ionic liquid may help for chemical recycling process. Now this is the flow chart for chemical recycling of PET glycolysis. It can the last product is the BET and monomer and oligomer, and methanolysis, by methyl alcohol we can get the dimethylene terephthalate and ethylene glycol, which is the raw material for synthesis of the PET. And hydrolysis process, by using the water treatment with the ethylene glycol, we can by hydrolysis process we can again back to terephthalic acid and ethylene glycol, which is the raw material for PET. That means chemical recycling process is one of the most important method by which we convert PET polymer to again monomer, by glycolysis, by methanolysis, by hydrolysis, and by other process. Depolymerization is done by various studies by different researchers, by using ionic liquid and castor oil, by biochemical depolymerization method, by eco-friendly process. It is enzymatic, by using some enzyme. The people are using some enzyme for removal from polymer to conversion of the monomer, and glycolysis process for heterogeneous reaction products. The objective of this solid waste management is nothing but the minimize the waste generation, maximize the collection of the efficiency of the waste, reduce the volume of the waste, develop and adopt the environmentally disposal methods. Need for waste management is nothing but the source reduction, reuse, recovery, composting, and incineration and landfilling is the process. So disposal is a main solution. Waste management, waste generation, storage, collection, and disposal for this material. If you see the PET consumption in worldwide, PET is widely used, consumed by the beverage industry to for making the bottles for soft drinks, and 34% in the globally used. And PET consumption is 2019 and onwards is gradually increases in worldwide. most of the problem is degradation. When after using, when we are littering in the environment, it takes longer time for degradation or decomposition. If you see the uh, different material for styrinated cup, aluminium can, nappy, and plastic bottle, fishing line, fishing net, if you see the scenario worldwide, it will take more than 450 years for decomposition of this material or degrade this material. So it will take longer time for decomposition, and moreover the consumption is gradually increases. We are throwing plastic here and there, and that will create the problem in sea, in river, in pond, and in land also. It will protect the growing of the grass, and it will, we are losing our environment and greenery day to day life. So recycling is the one of the most important solution regarding this, because if you go for direct burning, it will create problem in toxic gases in environment. So that is not suitable for direct burning. So how we can manage this material and recycle in proper way, by chemical method, by enzymatic method, by mechanical recycling method. I'll show you a video, very interesting video, where you can see how the people are making garments by using the waste plastic bottles. It is a very interesting video. I'll show you at the end of the session. Not now, I'll show you last after complete this seminar at the end. So you can see the after sorting segregation, and now sorting technology has came, NIR, near infrared technology has came, where you can sorted the plastic bottles in various ways, and you can recycle in various ways, by chemical treatment, by chemical recycling method, by mechanical recycling method, by enzymatic recycling method. Because this material time, this material takes and another 1 more hour. ठीक. This material takes degradation for longer time for degradation of this material. As you know, for plastic is basically non biodegradable material, because due to his hydrocarbon, carbon hydrogen chain bond is very much stronger, that will not destroy by the bacteria consume in environment, that will create the problem in environment. And so different technologies has came by using some catalyst, by using some various types of nano catalyst, nanotechnology has came for recycling this product. So more than 450 years is required for decomposition of this PET material. So what is the solution nowadays? Only the solution is the recycling and chemical recycling, where you can recover the monomer from the polymer to monomer by methanolysis, by hydrolysis, by glycolysis procedure. And you can mechanical recycling, you can get the different product as per the primary recycling. You can generate the direct bottle to bottle manufacturing, and by secondary and tertiary recycling, you can generate chemical recycling, you can generate the monomer, and you can generate the energy also by using the quaternary recycling method. The PET recycling is technology in the broad range of chemical recycling procedure, and it is available similar to that is virgin, and it protect the environment by dumping of soil. If you it enhance the economy and industrialization of the country. And chemical recycling used for decomposition polymer to monomer by glycolysis, by hydrolysis, and by methanolysis process. If you see for this year, again, if you see littering problem, lots of biodegradable, non-biodegradable material, and decomposition takes more than 450 years time for decomposition. Why plastic recycling is important? Because recycling takes less amount of the energy, and making the raw material for which is used for again for the production of the PET material. Recycling guidelines also appropriate for all PET bottle. This includes avoid use of the material component known as recycling process, include the quality of the recycled PET, recycling amount of the non-PET components to allow it is separation and efficiency of recycling, design components such as the closure label and easily, safely, cost effectively and by separated and eliminated from the recycled PET, and the global improving of the recyclability of the PET bottle cannot be compromised the product safety. PET material and its properties is very, if you see the specification and its properties, high strength, very high hardness and rigidity, very low moisture absorption because it has good barrier properties, good creep resistance, low sliding resistance, resistance to hydrolysis at very high temperature, not suitable for contact media containing alcohol, and good chemical resistance properties against including acid alcohols. So that's why soft drink bottles are made by using this PET bottle. Why recycling is important for PET material? Because unrecycled plastic have a negative effect on environment and economy. Recycling reduce the soil and water pollution and save the environment from the plastic bottles. More than one time you can recycle because it is a thermoplastic material, but basically it is one and its recycle code is one, and different recycle code is used for different material. The plastic material for PET material recycling code is one, that indicates that this is the PET material. So PET has some important characteristics: strength, thermal stability, gas barrier property, and also as light transparency, lightweight, transparency, and by using these, the beverage industries, particularly for bottle making industries, are gradually going on day by day. It estimated that around 35.8 million plastic bottles are every day used in UK, and 19.8 millions are recycled. So rest of the material may be dumped in land. So that will create the problem in environment. So recycling technology is a very important part for mechanical recycling, collection, sorting, segregation, washing, shredding, and cutting into a small pieces and extruding and compounding. These are the method by which we can make the various product. You can see when I'll show you the video, you can see the how people are making by mechanical recycling process after collection, after sorting, segregation, washing, shredding, and making the fiber by using the extruding technology. So mechanical recycling is one of the most important method by which you can recycle the plastic waste to garments, and so it is a very technologically important part. You can see the item wise in the packaging sector: clothing, shoes, carpets, soft drinks, furniture, sleeping bags, automotive parts, and various product you can made by using this recycled plastic also. Why recycling bottle is important? Because it reducing the greenhouse gas emission, it reducing the water pollution, it helps to reducing the land pollution, it saves our earth and environment. So recycling is necessary because it reducing the greenhouse gas emission, it reducing the water pollution, it reducing the air pollution. Advantage of the recycling helps to reduce the energy use, recycling save the earth, recycling helps to mitigation global warming and reducing pollution. Recycling minimize the waste product plus placed in landfilling. Recycling helps to save the money. Recycling spread awareness for the environment. So recycling is a very important term. So we can go for mechanical recycling, we can go for chemical recycling, we can go for enzymatic recycling, and various researchers are nowadays continuously work by using some various catalysts, by using some modification for improvement of the monomer, by polymer to monomer production percentage gradually increases by various catalysts. I'll show you some catalyst also. So 9 PET recycling technologies are there, where first of all, bottle to bottle, you can see some of the plastic bottle after using and cleaning and drying, you are making the same material. I have already told you a primary recycling, where you can make the bottle to bottle same product you are manufacturing from one product to same product, that is bottle to bottle manufacturing. If you see the picture, very important picture of the Coca-Cola, if you see the bottle to bottle manufacturing by primary recycling process, polyester staple fiber also made by extrusion process, and passing through the spinneret. I will show you some audio video regarding this. You see the mat carpet also made by this material, waste plastic you can make this material. You can produce the polyester filament, you can produce the polyester master batch, you can produce the tackifying reactive extrusion technology, you can make the nano composite with high barrier properties, with film making for film, and by using flame retardant characteristics. If you see the packaging sector, the transparent film is very important, so you can made by using this plastic material. So PET PE alloy you can made, and various advantages is there, and other modified material, and also you can make the plastic bags and clothes by using these plastics. So these 9 technologies, you can see the garments, you can see the various product by using the PET material. So PET technology is basically considered one of the most important and easiest material to recycle by primary, secondary, tertiary, and quaternary. This is also primary. This is called the zero water recycling techniques, where which involves the direct use of PET from waste material. The techniques used for recycling is basically the, if you see the plastic material, it goes in the various sector. After consumer product, after waste, it can reuse, and reuse to it can again consumer product. By mechanical recycling, it can go again the plastic material. By feedstock recycling, you can produce the natural gas and oil, and by waste you can also generate the recover of the energy generation by you. So these are the recycling, this is the flow chart, this is the model. You can this is a technique: raw material to consumer products, plastic material to consumer, PET material to consumer products, and consumer products after using, we are generating the waste material. And waste material reuse, by reusing we can make again the consumer products. By mechanical recycling, we can make the plastic materials again by using them. By mechanical processing, we can make the garments. By we can make the fiber. Feedstock recycling, we can generate the oil, and we can generate the energy also from this waste generation by quaternary recycling method. So this is a very important slide, because the after using lot of plastic bottles in environment, that will create the problems. So you can make reuse this product for various consumer products. You can make the carpets, you can make the transparent film by using some chemical or additives. You can make by mechanical recycling process by plastic material. You can feedstock recycling, you can get the natural oil, and as well as natural gas and oil. energy recovery, energy generation by this process is very, very important by using this waste plastic material. So sorting by mechanical recycling, when dumping is created by municipal solid waste. So lots of plastic material, plastic bottle, carry bags, every dumping people. So sorting and segregation is one of the most important method nowadays. The sensor technology has came for sorting this. So near infrared spectroscopy will help to sorting this material by absorbing the wavelength with this with the structure. So infrared sorting is used commonly waste industry to recover the material of value from the mixed stream. The technology use differences in wavelength of the infrared light and is reflected by polymer, which is different chemical structures. How the NIR measured? NIR spectroscopy based on the absorption of the electromagnetic radiation at the wavelength in this range, and it interact with the sample and detect to measure and absorbance. And absorbance is measured that will of the light that will absorb by the sample. So PET recycling is basically done by chemical recycling procedure, enzymatic recycling procedure, and mechanical recycling procedure. You know, for chemical recycling is a very, very important method by which we can recycle the various PET material by production of the polymer to monomer. Enzymatic recycling procedure also we can generate the raw material, oligomer, polymer, monomer, and other chemical valuable chemical, aromatic and aliphatics. And mechanical recycling, you can make the products such as garments, bottles, you can recycle this product. So recycling is a very, very important term which can save our environment. Otherwise, with increasing the demand of the PET bottles, it will destroy our nature, it will destroy our sea, ocean, and pond, river ecosystem will be disturbed. And a animal which is consume these bottles, bird, fish, and other animals, grass in environment field, it will destroy this environment. So recycling is one of the most important technique by which we can generate the monomer, polymer to monomer by chemical recycling process, enzymatic recycling process. Also, we can generate the valuable chemical, aromatic, aliphatic, hydrocarbons, and also some monomers also generated. And mechanical recycling process, we can generate the we can produce the different products by using this extrusion, and by using the molding, blow molding, stress blow molding technique, we can make the bottle also. So chemical recycling process, among the recycling method, chemical recycling is the most important method. And for sustainable development, it is for the recovery of the monomer. There is the three main methods for hydrolysis, glycolysis, and methanolysis. And For this process, the chemical path for depolymerization and improve the desired product and yield of this method means polymer to monomer you can generate, and which is again used for the formation of the PET material. So it is a very, very important method. Chemical recycling is one of the most important method by which you can recover the monomer from the polymer, and which is again used for the production of the PET material. So glycolysis, methanolysis, hydrolysis, all these processes are including this chemical pathway and depolymerize the PET polymer and convert it into the monomer. So if you see the reaction of this depolymerization by sulfolysis process, glycolysis is one of the very, very important term where you can convert the PET to monomer. Methanolysis process, you can see the methyl alcohol is used for the generation of the dimethylene terephthalate. In hydrolysis process, by using water, you can generate the terephthalic acid also. And again, these are these after depolymerization, this material again you can use for making for the production of the PET material, because these are the raw materials for that ethylene glycol, terephthalic acid, dimethylene terephthalate. These are the raw material for manufacturing of the PET material. So depolymerization is one of the most important method by chemical solvolysis process, by which you can make the polymer to monomer, and which is again suitable for the formation of the PET material and production. So these are the very, very important reaction: glycolysis, methanolysis, where we are using the methyl alcohol; hydrolysis, we are using the water by the elimination of ethylene glycol and terephthalic acid, which is the raw material for the synthesis of the PET material. So this term is very, very important for chemical method. This reaction is glycolysis, methanolysis, and hydrolysis. Glycolysis is carried out using the ethylene glycol, produce 2 hydroxy ethyl terephthalate, which is used for polyurethane foam, resin, and copolyester acrylic coatings and hydrophobic dyestuffs. Ethylene glycol, propylene glycol may be used for solvent in PET glycolysis process. Besides its flexibility, glycolysis is the simplest, oldest, and latest process, and this reason the attention have been developed for the glycolysis process. So by glycolysis, by methanolysis, by glycolysis process, we can recover the monomer, and which is again used for the production of the PET material. By methanolysis process is a degradation of the PET material, PET to dimethylene terephthalate and ethylene glycol by using the methanol. Disadvantage of this process is a very, very high cost. In spite of this, they also it is very difficult to separation of the catalyst in this process, but still some procedure is there for separation of the dimethylene terephthalate and ethylene glycol by using the methyl alcohol, which is the raw material for the synthesis of the PET material. Hydrolysis process, you see, for the we are using water as a hydrolysis process, which is used for the making for the production of the ethylene glycol, and also water is used for making the ethylene glycol and terephthalic acid, which is the raw material for the synthesis of the PET material. If you see the catalyst used for glycolysis process, the different catalyst used: zinc acetate, titanium phosphate, lead acetate, sodium carbonate, sodium bicarbonate, acetic acid, lithium hydroxide, sodium sulfate, zeolite, zinc chloride, magnesium chloride, zinc oxide, silica nanoparticle, magnesium oxide, silica nanoparticle, ionic liquid. So different types of catalyst also play a very important role for the production of the high production of the polymer to monomer. The percentage yield of the BACT will vary from temperature catalyst use in the PET glycolysis process. So catalyst is play a very, very important role for the conversion of the monomer with high yield percentage, and temperature also. Catalyst, time, temperature, these three terms is very, very important. Which catalyst you are using, at what temperature you are carried out the glycolysis process, that is very important term. That depends upon the conversion of the monomer and yield of the monomer, that depends on this percentage yield of the monomer, that depends upon these three terms: temperature, time, and catalyst, which is used for the PET glycolysis process. PET glycolysis with and without catalyst, it has been various research has been developed the various catalysts. The glycolysis process, it has been experimentally verified that without catalyst and with catalyst, the presence of catalyst, the reaction is very fast, and yield also very fast. That depends on the temperature, I have already told you, and time of reaction, and which types of catalyst you are using the system. So researchers are going a different reaction. Thus, the trans-stratification catalyst have been applied in the reaction of the PET glycolysis process, and it is most popular, and it enhances the glycolysis rate also for trans-stratification. So catalyst use, basically I have already told you, zinc acetate play a very important role, and percentage of the yield of the polymer to monomer with this process is very high. That will vary with temperature, time, and catalyst use from system to system. The oldest reported catalyst is the metal salt. Zinc acetate are the first used catalyst for the synthesis of the polyester. Metal acetates such as the zinc, manganese, cobalt, and lead as used as a catalyst. Zinc acetate showed the best result in terms of the extended of the depolymerization reaction of the PET. The equilibrium between the BHET monomer and dimer also reached after 8 hours reaction at the temperature 190 degrees centigrade, with the high percentage conversion of the BHET monomer by using the depolymerization process, using zinc acetate as a catalyst, and uh, temperature and time is a very important. 190 degrees centigrade temperature and an 8-hour reaction, more than 95% yield of the polymer to monomer by using this catalyst. So role of the catalyst is very, very important for glycolysis process. So zinc acetate play a very important role for the synthesis of the polymer to monomer. Metal acetate, zinc acetate showed the best result for the depolymerization, and this depolymerization will carry out reaction at temperature 8 hours and 190 degrees centigrade will give the best result, means conversion of the polymer to monomer. Yield percentage is very, very high using the zinc acetate as a catalyst. If you see the high surface area catalyst for nano-composite eco-friendly catalyst is used, zeolite have been used as a catalyst in the reaction and for the conversion, because it will provide numerous active sites that will helps to produce the BHET monomer, and also significant improvement by using the other catalyst also. So nano catalyst also play a very important role. Some ionic catalyst also applied for the PET glycolysis process, and different ionic catalyst have been used by using the various researchers using various temperature. 100% conversion of the PET was achieved after 8 hours at a temperature of 180 degrees centigrade with 1-butyl 3-methyl imidazolium bromide being the best catalyst in terms of the PET conversion in case of the cost cost consideration. So conversion of the yield of the polymer to monomer, that depends upon the which types of catalyst use: ionic catalyst, nano catalyst, and also some metal salt catalyst such as the metal acetate. Zinc acetate is the first synthesis polyester by glycolysis process from polymer to monomer. এখনো 30 মিনিট আছে, 10-15 মিনিট হবে, তারপর ভিডিওটা দেখি তো। So ionic catalyst also helps for the PET recycle process, and different ionic liquids and perform the glycolysis reaction in presence of these ionic liquids, and conversion of the PET polymer to monomer depends upon the temperature, time, and the catalyst used in this system. And in this case, for ionic catalyst, for 1-butyl 3-methyl imidazolium bromide being the best catalyst by reported by the various researchers for the conversion of the PET polymer to monomer in cost consideration. Solvolysis process by using some solvent, by using zinc acetate catalyst PET glycolysis reaction, 80% BHET yield and higher yield is used by using without xylene. The main objective of the xylene was initially the miscibility with the PET glycol mixer at a temperature 170 degrees centigrade and 225 degrees centigrade. Ethylene glycol dissolve sparingly, and xylene, while it dissolve readily in PET, meanwhile glycolysis products are soluble in xylene. Therefore, the reaction progressed by glycolysis product moved from ethylene glycol phase to xylene phase, shifting the reaction direct of the depolymerization. So by using the solvent also, it enhance the glycolysis process. In this case, the time, temperature is play a very important role for the producing polymer to monomer. Supercritical glycolysis, the use of supercritical condition has been explored by various researchers in the PET by methanolysis and by recently by glycolysis process. The main advances of the supercritical fluid play a very important role, and to eliminate the need of catalyst, and difficult to separate the reaction product, and it is also environment friendly. The ethylene glycol in its supercritical state and supercritical process was carried out at 450 degrees centigrade temperature and pressure 15.3 megapascal, they compared with the subcritical process where the BHET dimer equilibrium was achieved much earlier. For the supercritical process, BHET yield 93.5%. This is in very short time by glycolysis process within 30 minutes. Owing to high temperature, pressure, and supercritical glycolysis delivered a very high yield of BHET monomer. So suppressing the yield of the side products 0.69 diethylene glycol yield almost negligible formation of the oligomer, BHET dimer, and ethylene glycol. If the economically feasible supercritical glycolysis may be used to replace the catalyzed glycolysis process. So here, very important term, the supercritical glycolysis process, time, temperature, and the glycolysis reaction is very important, where the process they convert the polymer to monomer conversion is very high within short period of time. More than 95% polymer to monomer we can achieve by this process. Microwave assist glycolysis process in another most important term by eco-friendly catalyst used for microwave radiation, and employment of the microwave radiation heating sources directly decrease the time. So time is a very important factor. Microwave it did not increase the yield of the monomer, but very shorter time we can use very efficient manner by using the efficient catalyst along with the microwave irradiation heating to increase the yield of the BHET with decreasing the reaction time. So microwave assisted by using the microwave technology, microwave radiation, we can reduce the time for this process, glycolysis process, and irradiation by heating, we can increase the monomer percentage, monomer production of the monomer percentage of the BHET monomer percentage. In enzymatic technology, enable of the various enzyme used for recycling of the PET material, most important manufacturing for bottle, polyester and clothing fiber, container, etc. By novel enzymatic process, we can recycle this polymer to monomer. Depolymerization of the PET using the enzyme was first described by 1917 by two researchers, Tokiwa and Suzuki. They use this enzymatic procedure and ionic liquid and castor oil biochemical method developed and eco-friendly procedure for polymer recycling, methanolysis and glycolysis procedure. Here the PET is incubated in presence of enzymatic solution at a temperature 30 to 60 degrees centigrade for 3 to 14 hours. So the residual PET were separated for the production of the characterization, and depolymerization was done by using the various enzyme. So we can convert the polymer to monomer by using this process, by enzymatic process. Another optical sorting procedure is that I have already sorting NIR technology is used, and another the sensor based sorting technology also helps to segregate the plastic waste from dump. And also we can generate the fuel energy by quaternary recycling process. Statistical shows that the 10% of the plastic is recycled and 20%, 25% is incinerated, and 60% is 65% is dumped in land. So incineration also alternative for landfills and the formation of the unacceptable emission of the gases, sulfur dioxide, dioxin, trioxin, like this. So mechanical recycling is a very important for these cases. You see, the plastic also used for road construction, aggregate, bitumen and plastic waste, which is used for various road construction purpose. Basic technique, energy recovery, and energy can be recovered by this process. Thermochemical conversion, this process entered the thermal decomposition of the organic matter to produce heat energy, fuel or gases. So we can generate the fuel also by pyrolysis procedure. We can generate the fuel, we can generate the energy by using this waste plastic material. And biochemical conversion, this based on the enzymatic decomposition of the organic matter by microbial action to produce methane gas or alcohol, which is useful product. So by using this waste plastic bottle and other plastic waste, we can generate the fuel by pyrolysis procedure, by thermal conversion, and this procedure decomposition of the organic matter, either heat energy or fuel or oil or gases. Biochemical conversion, this process is based on the enzymatic conversion of the microbial action to produce methane gas and alcohol. So energy we can recover by using these waste plastic bottles. We can generate the fuel, we can generate the gases, we can convert the various gases like methane and chemicals or alcohols by enzymatic decomposition of this waste plastic material. Now the challenges and opportunities. Zinc acetate was the first used catalyst to obtain 60% of the BHET after yield 8 hours reaction until and silica nanoparticle metal oxide catalyst were applied, obtained at least 90% yield after 18 minutes. PET glycolysis, including operation due to its long reaction time, yields severe condition and pollution problem. Researchers developed the catalyst to increase the rate of glycolysis process, environment friendly, and reduce time by using time temperature, by using the various catalysts. The main challenge is to stand now to deliver the efficient and sustainable eco-friendly environment by reducing, by recycling, by chemical method, by mechanical method, by enzymatic method. How we can recycle these waste plastic bottles and other products, and we can save our environment by reduce, reuse, and recycle. There are many methods also for break down the chain for polymer, paid polymer. Nanotechnology also helps to recycling this process, and advancements of the PET glycolysis process. Ultrasound assisted depolymerization has been applied to other polymerization depolymerization process. Nanotechnology based developed more highly efficient glycolytic depolymerization of the PET. Now I'll before going to show, I can show a video where you can see the mechanical recycling, how people are making the garments by waste plastic. You can see the video, very interesting video. Now প্রথম থেকে file আছে, how will go.
But first, in the UK, we throw away billions of plastic bottles every year. We're getting much better at recycling them, but did you know that they can also be turned into clothing? This amazing process starts here at the Bottle Recycling Centre. The first stage is shredding. When you throw away your bottle, you often leave a small amount of drink inside. Shredding all the bottles releases the unwanted liquid, so it doesn't affect the quality of the plastic. The shredded bottles are then wrapped in cellophane and boxed up, ready to be shipped around the world. It may be rubbish to us, but to the Chinese textile industry, this plastic waste is a valuable commodity. Recycled bottles arrive from all over the world to feed the busy clothing industry. Sorting separates the clear plastic from the colored stuff. Clear plastic can be made into white clothes or material that can be dyed, so it's extremely valuable. Most clear plastic bottles have colored lids and stickers on them, but these have got to go, so the bottles head for the baths. The colored caps are made of a different plastic which floats. A worker can then strain them off the top. Then there's a separate bath for the stickers, but the workers have to be careful around this one. It's corrosive caustic soda, very bad for the skin, but very good for removing labels. After all their swimming, what's left is a pile of clear plastic shreds. But it's rather wet. The next step is the ovens, where it's mixed with some light-coloured plastics. To produce white cloth, you need some light-shaded material in the mix. The plastic will spend about 10 hours here in these rotating drums, slowly drying out. These workers have to maneuver their cart back and forth underneath the drums to catch the plastic as it falls out. But they've also got to mind their heads on all the other spinning ovens. So we've got our plastic bottles broken down and mixed to produce the right colours. But it's very hard to weave cloth from bits and pieces, so another step is needed. The mixture is sent through this rotating screw, where it's heated to 270 degrees Celsius. This melts the plastic, but to make cloth, we don't want a big lump, we need thread. The liquid plastic is forced through a sieve and emerges on the other side as great long strings, which are collected in a container below. We've now got thread, but it isn't strong enough to make cloth yet. First, it must be combined and stretched several times while being heated. This will bond the fibers together. Now, it's taken ages to produce this material, but the next part of the process is to tear it apart again. The fluff that emerges is the raw substance you need to make polyester. However, that takes place in another factory altogether, so the workers here bale it up and send it on. It looks like cotton wool, but it's an entirely man-made substance created from your old bottles. This machine scrapes it all onto a very rough cloth, which is loaded here, ready to be carded. Carding is where the bonded fibers are brushed together so they all lie in a similar direction, which strengthens the material. The sheet of polyester felt that emerges is now ready to be turned into thread. These machines will tease it out. They spin off mile after mile of pure polyester, which is collected on these bobbins. And finally, we reach the point where your old plastic bottles become cloth. Like a spider at the center of its web, the loom draws in thousands of threads and weaves a new sheet of polyester. To give it a smoother feel, there are still two more processes to go through. The first is very delicate. This machine creates tiny loops on its surface. The second stage is the opposite. Using a series of tough steel brushes, these spinning rollers catch and tear all the carefully made loops. The shredded surface helps give the material a soft, furry feel, making it far more comfortable to the touch. So we've turned our recycled bottles into polyester at last. Now it's time to make some clothes. Using a roll of material, stylists mark out the latest designs, being as economical as they can with their handy template. Although they're profiting from your rubbish, they don't want to create any more waste. The pieces will then be sent to workers who turn your trash into the trendiest gear you can find on the high street. So what started out as your rubbish was carefully sorted, then shredded, and turned into cloth. That cloth was shredded into fluff, spun into thread, and turned into fashion, from plastic bottles to polyester clothing.
That is on the thank you go slide ये slide टा देखो slide टा जहाँ देखो skip कर दिया this is last slide है चलेंगे So thank you all for listening my lecture, and if any queries you can ask question. So people are making the this video shows that the people are making plastic bottles to garment, plastic bottles after chemical treatment. They are producing the fiber, and after knitting, washing, cleaning, they are passing through the extruder, and they are making the fiber, passing through the spinneret, and after that they are making the cloth, garments by using this waste plastic bottle. So this is the mechanical recycling process, and garment industry, particularly in winter session, whatever the garments and warm cloth based on the polyester we are using, that is basically recycled PET material. So we can use this technology. By the help of this technology, we can make the various garment clothes by using the mechanical procedure. So mechanical recycling, chemical recycling, enzymatic recycling nowadays a very important role. Catalyst, nanotechnology also play a very important role for enhancement the process technologies, and also by recycling process. With this, thank you all the participant. If any question, please ask me. Sir, I want to nanotechnology in depolymerization. Yes, sir, nanotechnology. Slide back. Slide. উপরে 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 ন্যানো টেকনোলজি, না আরো উপরে উপরে বোধহয়, উপরে উপরে আরো অনেক উপরে। Nanotechnology, like people are using the geolite like catalyst, which will helps to improve the catalytic activity, and it will provide the numerous active site, which will helps to improve the more production of the BHET material. So nanoparticle nanotechnology also helps to improve this process for recycling process. Means that is the part of this process. Means we are converting the monomer polymer to monomer by using, by the help of the catalyst, and nano catalyst that will play a very crucial role. By using this catalyst, they will play a numerous active site. They will provide the multi-active sites, which will helps to improve the yield of the monomer, right?
Anyone else is having any queries? Yes, dear participants, if you are having any queries, then you can ask. Dr. Mandal is here. So no queries? Okay then. Indeed, it is a very nice presentation. We all have enjoyed this session thoroughly. We learned many various methods how to recycle polyethylene terephthalate, and particularly the bottles and others. So we hope from this session we'll be learning how to segregate the basic plastic materials so that it will be easier for recycling of those daily or single use plastic. Thank you all the participants for patiently listening to Sir's lecture and being an wonderful audience. I thank Dr. Mandal for addressing our participants for regarding this recycling of PET and explaining very having a wonderful session. The presentation was superb and we have thoroughly enjoyed this session. Thank you, sir. Thank you for giving your valuable time for addressing our participants.
Thank you all the participant from my end, and thank you madam for giving me the opportunity for this session. Thank you all, thank you, bye bye.
So participants will be joining for a second lecture at 12 noon. From 12 to 1:30, we are having another session. So you please stay connected, or if you are having a break, then please join through the same link. Thank you.
ये कहाँ क्लिक कहाँ बाहर होंगे कहाँ ऐसे भालो है ठीक
वही तो वही कॉन्फिडेंस चाहिए
कॉन्फिडेंस 2 मिनट
Yes, sir. Dr. Alamelu, sir.